In Chapter 8, we work with polynomials the entire chapter. And then pretty much the rest of the year, actually, we're going to be working with polynomials, things that have exponents on them, like in Chapter 7. We're working with actual equations and functions and things like that that have exponents this time. So, Section 1 is called adding and subtracting polynomials. It's the most basic thing that we can do. When you're adding and subtracting numbers, that's like the most basic thing that we know how to do. You learn how to do that back in like the second grade or something. Kindergarten? Adding and subtracting? Oh, you didn't understand what the addition actually meant. Okay. So we're adding and subtracting polynomials here. The addition process and the subtraction process is the same. You just have to adapt the way that you think about adding and subtracting a little bit. So in this chapter, we're studying polynomials, how to add, subtract, multiply, and factor them. You'll hear me say factor, but what's meant by factoring is actually dividing. Anytime you factor something, you divide. We're going to quickly get into factoring in this chapter. There's also a lot of vocabulary to learn, even some vocabulary words that aren't listed on that front page of your note packet that you'll have to learn. If it's a vocab word, make sure you know how to use it, and use it whenever you can. So first of all, monomial. Anybody know what a monomial is? You've heard of it. What is it? Well, yeah, if you look at the word monomial, it has a prefix in it. What's that prefix that I'm talking about? Mono. What does mono mean? One. Like if you go down to Disney World, there's a monorail because it runs on one rail instead of two like a normal train does. The prefix mono means one. So a monomial is a real number, a variable, or a combination of those two, and the result is the monomial part. The mono part means basically what you have is one term. That's it. That's a monomial. If all you see is one term, then you have a monomial. And if you're not sure what a term is, you'll know here in a couple minutes. Is what? No. No. So if I had some examples of a monomial, this would be one. Let me put it here. 2x. That's a monomial. 2 times x. The number 5, that would be a monomial. Any number by itself is a monomial. Any variable by itself, so I could have just y, that would be a monomial. Or I could have a combination of those things, like negative 4y to the 3rd power. By itself, that's a monomial. I could also have something like 3x squared y. That's a monomial as well. There's only one term. Each one of those is one thing. It's a bunch of stuff being multiplied together, but it's all just one thing. A polynomial, what does poly mean as a prefix? Just 2? Just 3? So what? Give me one word, if it could be 2 or 3 or 4 or 5. Huh? Multiple? Several? Many. Yeah. The prefix poly means many. Okay, there's lots of words out there that start with poly, and they all mean many. So what I'm going to write here is a collection of monomials being added or subtracted. So now if I have a bunch of monomials and I put them together, but I keep them separated by either addition or subtraction, what I've done is created a polynomial. So for example, 4x squared, that's a monomial. But as soon as I put on a plus 2x, that 2x is also a monomial, but now they're being put together by addition. That makes it a polynomial. If I put in a plus 5, I still have a polynomial. I just have one more term. The word you don't see up here is term. So based on what I just said, what can you say a term is? A term is each individual thing. Like if this right here is a polynomial. This right here is a term. This is also a term. This is also a term. Each individual thing in a polynomial is called a term. Okay, so how many terms are there in this polynomial? There's 3. How many terms are there in this polynomial? If it's a monomial, there's 1. Yeah. Okay, so then what would a binomial be? Yes, very good. It's a polynomial with 2 terms. So you'll hear me say binomial a lot. And what I mean by a binomial is just a 2-term polynomial. What about a trinomial? 3 terms. So it's a 3-term polynomial. Those are the only 2 special terms that we have for polynomials. Well, there's 3 actually. Monomial, 1-term polynomial. Binomial, a 2-term polynomial. And trinomial, a 3-term polynomial. Anything more than 3 terms, and we just call it a polynomial. There's no special words for any of those anymore. So what could we call this example that I had up here? This is a trinomial. It's also a polynomial. All trinomials are polynomials, okay, automatically. It's a 3-term polynomial. If I put another term out here, like maybe a 5x to the 3rd, now what do we have? No, there's no special name for it. So it's just a what? It's just a polynomial. But what if I got rid of these 2 terms here? Now I just have, now it's a binomial, right? And what if actually I didn't have that front term either? Now it's a monomial, all right? How many terms do I have in this polynomial if I go back to all 4 of those terms? How many terms do I have? I just said it. I have 4 terms. There's 1 here, 1 here, 1 here, 1 here. Okay? The sign that you see on the term goes with the term. So, like if I had 2x squared minus 5, I'd have a term here, it's 2x squared. But this term right here would actually be negative 5. The sign goes with the term. Degree of a monomial. So here's another vocab word. The degree of a monomial is the sum. I'll explain it in a minute here. Let's just get the definition down. The sum of the exponents. Underline the exponents. On all variables in the term. So you're adding up all of the exponents that you see, adding all the exponents that you see on all of the variables only in just one term. So therefore, for that 5x, what is the degree of that monomial? Why is it 1? Because if there's no exponent, then there actually is an exponent. It's a 1. So therefore the degree of this monomial is 1. What would the degree of the 6x to the 3rd y squared be? 5. Good. Because 3 plus 2 is 5. And what would the degree of the next one be? You are adding up the exponents on the variables. You don't have any variables. So the degree is 0. Here's why. What is anything to the 0 power? 1. So if I had something to the 0 power here, like maybe x to the 0 power, what is x to the 0 power? And then it's 1. And then 1 times 4, though, is 4. So did I change this monomial at all by doing that? No. And now I do have a variable with an exponent on it of 0. And that's why the degree on this guy is 0. So I'm going to put a little box around this so that I don't wind up looking like an egg. Now you have an egg. How about the next one? It is 2. Yeah, because there's an exponent on that x of 1. There's an exponent on that y of 1. And then we add the 1 plus 1, and we get 2. So those missing exponents are kind of tricky. This takes practice. How about the next one? Negative 7 y to the 4th z. It is 5. Good. And the last one is, why is it 1? 5 to the 3rd is what? Well, what is it? Yeah, it's 125. So this just isn't simplified, which we know from the last chapter is wrong. We would have to rewrite that as 125x. And now, even though I saw a 3rd power here, this 3 is not attached to a variable, so I'm not going to add it into my degree calculation. What is the degree of this monomial? 1. By the way, all 6 of these, are they polynomials or not? They're all monomials, but are they polynomials?
No.
Yes.
Oh, it's like squares and rectangles.
That's right.
All rectangles.
All squares are rectangles, but not all rectangles are squares. All monomials are polynomials, but not all polynomials are monomials. Good. Good analogy.
I was going to say that earlier.
So if you have a monomial, it is a polynomial. It just only has one term. Okay? Okay, so the name of this section is called Adding and Subtracting Polynomials. So first we're going to learn how to add and subtract monomials. And when you add or subtract, think this. Combine like terms. You've been combining like terms all year. We're doing the same exact thing here. You just got to learn what a like term looks like when you're talking about polynomials. Like terms, here's your definition. All variables and the exponents on those variables must match perfectly. If they don't, they are not like terms. So the variables all have to be the same in each term, and the exponents that are on those variables have to be the same in each term. Otherwise, they are not like terms, and you cannot combine them. You just leave them as is. But if they are exactly the same, then you can combine them. So on this first one right here, we have 3x squared plus 5x squared. And what I want you to do first, we'll get away from this pretty quickly once you understand what a like term looks like. But let's think of this as like 3 apples plus 5 apples. If I take 3 apples and I add 5 apples to it, what do I have? 8 what? Apples. Did I wind up with 8 apples squared? No. Did I wind up with 8 double apples? No. Did I wind up with 8 oranges instead of 8 apples? No. I wound up with exactly what I had to begin with, 8 apples, okay? So if I have 3x squared plus 5x squared, this is like having 3x squareds, 3 apples. This is like having 5x squareds, 5 apples. If I put them together, how many x squares do I have? 8x squares. So that's why this winds up being 8x squared. You do not add the exponents here. And that's the tricky thing, because in the last chapter we were adding the exponents. But that was when we were multiplying like bases. We are not multiplying like bases here. We're combining like terms. So that's a tricky thing to kind of wrap your mind around. You're going to have to really kind of concentrate on that sort of thing for this chapter. But that is what's happening here. We're combining like terms. 3 apples plus 5 apples is just 8 apples. 3x squares plus 5x squares is just 8x squares. Okay? Now, take a look at the second one. We have 4x to the 3rd y minus x to the 3rd y. Are these like terms? For them to be like terms, the variables have to match and the exponents on those variables have to match. So in this term I have an x and a y. In this term I have an x and a y. In this term it's x to the third, y to the first. In this term it's x to the third, y to the first. Did the variables and exponents agree? Yes. Therefore, these are like terms. What's the number in front of that? It's a 1. Anytime we don't see a number in front, we can assume there's a 1 there. So now what I see is 4 apples, basically, minus 1 apple. If I have 4 apples and I take 1 away, what do I get? 3 apples. So here this is 4x cubed y's minus 1x cubed y, which leaves me with 3x cubed y. There's your answer. Okay, they have to be like terms before you can combine them. But once they're like terms, you combine them just like normal. And the variables and the exponents stay the same. That's the key. They do not change. And I have that sitting right here. The exponents do not change when you're combining like terms. It's probably the trickiest part. All right, let's take a look at this one. By the way, what would this be called here? It is a polynomial, and it has 3 terms, so we could just say trinomial. What would this one be called? It's a binomial. What would this one be called? And this one? And this one? Trinomial. And this one? Binomial. They're all polynomials. Okay. So, do we have any like terms in this trinomial? Not all of them are, but do we have any at all? Yes. We have an x squared y to the 4th. So I'm looking for another x squared y to the 4th. X to the third y to the 4th, that's not like terms, so I can't combine those. X squared y, but not to the 4th. Are those like terms? No. So this one is not like terms with this one or with this one. But is this one like terms with this one? No. So do I have any like terms here? No, I don't. I can't combine anything. That stays put. That is already in simplest form. You can't do anything with it. Okay? If there was a 4 on that y, could I combine like terms? If that was y to the 4th, then yes, I could. But it's not, so I just got to let it be. All right, let's see if you can do those bottom 3 here, and then we'll talk about them. How about the bottom left? Are those like terms? Got some head nods. Negative 6x to the 4th plus 11x to the 4th. I get negative 6x to the 4th, and then I'm adding 11x to the 4th, which gives me 5x to the 4th. After some practice, you'll get to the point where you don't have to sit there and think things like that. You'll just be like, oh yeah, that's like terms, and I can just combine them. Yeah, that's a good point. Notice that we're back to adding and subtracting integers again. Stuff that we did way back in the beginning of August, and I was like, you guys got to know how to do this, because that's what we're doing all year long. Here it is again. All year long. Never stops. Oh, there was a song? Nice. I should bring Mr. Jordan over for that. I don't sing. I'm not a singing teacher. How about the middle one? Do we have like terms anywhere here? Yeah, we do. Where? 5x squared and negative 2x squared becomes 3x squared. And then I have that plus 3x. Are those like terms? No, they're not. So that's the answer right there. And how about this last one? Do we have like terms here? How many terms are there in that one? There's 2 terms. Good. Those are like terms. So when we combine them, what do we get? Good. The variables and the exponents on those variables stay exactly the same when you're combining like terms. You just basically combine the numbers and the stuff stays the same. So 8 through 23 all. It is all. Make sure you notice that. So I don't know how many problems that is. It's probably like 16 problems. Just a guess. But they're all like this, so they shouldn't take very long per problem. So make sure you're checking your odd answers, and just be careful about like terms for your even problems. You shouldn't have any trouble with those. We'll come back and start some more stuff here in a few minutes. Here are a couple more vocab words that we got to deal with here. Standard form of a polynomial and degree of a polynomial. So we already know what a degree, the degree of a term is. Talked about that. But what is the degree of a polynomial? So first of all, standard form of a polynomial is when the polynomial, it's kind of a long definition here. Polynomial is written with the polynomial gets written with the highest degree term first, and then you write each sequential lower degree one after the other until you have the lowest degree term last. So I'm writing the polynomial is written with the highest degree term first, then on down to the lowest degree. Term. So the polynomial is written with the highest degree term first, then on down to the lowest degree term. So you got to figure out what the degree of each term is and then put them in order from highest degree to lowest degree. So the degree of the polynomial then is the degree of the term with the highest degree. So it's the degree of the term with the highest degree. If you put it in standard form, it would be the degree of that front term, because that's the term that has the highest degree. Whatever that degree is the degree of the whole polynomial. You don't add all of it together, just term by term. So what is the degree of this first polynomial right here? Take a guess. It's 5. Yep. Because the degree of this term right here is what? 5. The degree of this term right here is what? 0. Not 1, because there's no variable on it. That's a degree of 0. Well, the term that has the highest degree is this guy with 5, which makes 5 the degree of the whole polynomial. So what's the degree of this polynomial? There's a 5 here, but remember there's a 1 on that x and there's a 1 on that z for a total of 7. There's only one term, so since there's only one term, the degree of the whole polynomial is 7. Has nothing to do with that 7. That's a coincidence. How about the degree of this polynomial? 4. What's the degree of this term? 2. What's the degree of this term? 3. What's the degree of this term? 4. What's the degree of this term? 0. Which term had the highest degree? This one did with 4, which makes 4 the degree of the polynomial. Okay? It's just the term with the highest degree. That degree is the degree of the whole thing. You don't add them all together. All right, so now that we know how to find out the degree of each term, we can put things in standard form. You find the term that has the highest degree and you write it first. And then the next highest degree, write it next. And on down until you have all the terms taken care of. The sign stays with the term. That's the hardest part. So whatever sign you see, it stays with it. So in this problem, what's my first term going to be? 4x to the 5th. That's the highest degree term. So I write 4x to the 5th first. And if you want to, if you have like a quiz in front of you or something, or you've written the problem down, you can go ahead and cross that term off and then you know it's gone. You have to use every term. So what's the next highest degree term? Yeah, it's this guy right here, the 3x squared. That's a positive 3, even though you don't see a sign, so I have to write plus 3x squared. And that term's gone, and then that sign stays with that last term, minus 7x. Now it's in standard form. What's the degree of that polynomial? 5. What kind of polynomial is that? It's a trinomial. Good. So let's take a look at the second one here. What's going to go first? A what? It's negative. Remember, the sign goes with the term, so that whole thing right there is the term. So that's a negative 2y to the fourth. And what's next? Right, that whole thing, the sign and everything goes with that term. So it's minus 6y to the third. That's a positive 5y, so I write plus 5y, and then minus 9. And I'm done. I've taken care of all 4 of those terms. What do we have here? It's a polynomial. There's more than one term. And it's more than 3, so we don't have a special word for it. What's the degree of this polynomial? It's a 4th degree polynomial. And go ahead and do those last 2, and we'll come back in about 30 seconds. What will we have for that one? Yep. Yep. Good. And that is a trinomial because there's 3 terms. And how about this one? You can add those. Notice that we have 4x sitting here and a positive 7x sitting there. Those are like terms. I can combine them. What do I get? 11x. So I write plus 11x minus 1. So that started out with 4 terms, but because of those like terms, we combined them and it became a trinomial. Yeah. So watch out for like terms. You can still combine them as you go. You can combine them first and then put it in standard form. You can combine them after you put it in standard form, or you can combine them as you put it in standard form. Okay, a little summary table here, and then we'll be done for the day and you can work on those problems. You can name a polynomial based on its degree or the number of monomials that it contains. In other words, the number of terms that it contains. So if you have a polynomial that looks like this, just 6, what is that? It's a monomial. So that's why over here they said it's a monomial. We have a special name for a monomial. It's just a number. It's called a constant. This one right here would be called what? It's a binomial. So that's why over here you see the word binomial. And if I were to graph that, what would I see? If I had like y equals 5x plus 9, what would that look like? It'd be a line. And that's why this one happens to have a special name called linear. It's a 1st degree binomial. What is this one? It's a trinomial, so that's why we have trinomial over here. There's 3 terms. The degree of this trinomial is what? 2, and that's why you see a 2 there. And we have a special name for that one. It's called quadratic. And we're going to be dealing with quadratic equations. That's coming next. We haven't quite done that just yet. But when you graph those, they look like this. And we know what that's called. I've said it a lot. The parabola. What is this one? It's a monomial. There's only 1 term. What's the degree? 3. So we have 1 term. It's called a monomial. It's a degree of 3. And there's a special word for that guy. It's called a cubic polynomial. And finally, we have a 3-term polynomial here, which makes it a trinomial. Its degree is 4. We have a 4 sitting there. That's a degree of 4. So that's why you see a 4 there. And that's called a 4th degree. There is a special name for it. You don't need to know it now. It's called a quartic trinomial. Quartic trinomial. So this is just how you can categorize your polynomials based on the degree using this column or the number of monomials, the number of terms it contains using this column. So on the homework, there's some problems that ask you to categorize the polynomial. You want to use that chart to help you name that polynomial correctly.